This is lesson 81 on 166 and 167. And it is trig ratios. Now, that's a short abbreviation for trigonometry, which I actually, trigonometric as the adjective, and I'm going to write it on the top of the assignment page. Trigonometry with triangles is the relationship of the sides in a right triangle. Mathematicians many years ago realized that no matter the size of the triangles, that there was a relationship between the ratios, which we just know is, like a side over a side. It's a fraction in Lewis terms. So we're going to first draw just a generic right triangle and talk about the ratios themselves. The word is trigonometry and then trigonometric, and I tend to just abbreviate it trig. It's about the only time you'll see me write it. Okay. In a right triangle, you've obviously got three sides, and we're going to call those little side A, little side B, and little side C. And then we usually name a triangle by its angles. We'll name a triangle XYZ, whatever. So we're going to call the side across from this angle, try that again. Side A is going to be across from angle A. So this is angle A, and then that's the side across from it. So in this case, our hypotenuse is C, and then this would be angle C, which is the right angle. And then B, this will be angle B up here. So side B and angle B are going to be across from each other. Well, the basis for everything that we look at with right triangles is the Pythagorean theorem, which, just as a review, is leg squared plus leg squared equals hypotenuse squared. Which a lot of people, if you say, what's the Pythagorean theorem, they'll say a squared plus b squared equals c squared. And my reaction is, what are those? Well, that's why if you know that a and b are the legs, you can say this. Now, I do notice in some of the examples that we have, I'm usually used to C being the hypotenuse, but I think in some of your classwork, they may label the angles a little bit different. So just be careful. C is not always going to be your right angle. Well, the mathematicians, now within triangle trigonometry, right triangle trigonometry, we don't talk about the measure of, we don't use the right angle. We're going to use the two acute angles. If you remember 180 in a triangle, that these add up to 90 degrees. And so we're going to use these two angles. And we can talk about three ratios, three relationships. We can talk about the sine of an angle. And we usually abbreviate that SIN. It's still pronounced sine. It's pronounced sine, even though it's written as an abbreviation. So it's not sin, it's sine. And then usually we put the letter here, like angle A or angle B, but I'm just going to put angle. And then when we get into specific examples in just a minute, I'll show you how we're going to write them. And so the sine of an angle is its opposite leg over its hypotenuse. Okay, for any right triangle, opposite leg over the hypotenuse. Now, the next one, cosine, the whole word is cosine of an angle. The abbreviation is COS, still pronounced cosine, not cos. And it is the adjacent leg over the hypotenuse. And I'll show you an easy way to remember these in just a moment. And then the third one, the tangent of an angle, abbreviated tan, but still pronounced tangent, is going to be the opposite leg over the adjacent leg. Now, there are three more, but those are the ones, the reciprocals of these, but this is what you tend to use until you get to college algebra or pre-cal, something like that. And this is what the ACT covers too. So with an abbreviation using this triangle up here, which I think you can still see, we'll do just a couple of examples. We can say the sine of angle A. Now, I have always usually put angle in it, but most of the time the notation is just sine of A, meaning that angle A. Well, the definition says it's the opposite leg over the hypotenuse. So in angle A, This is a leg, and this is a leg. Now look at the difference in opposite leg and adjacent leg. Opposite leg is going to be the leg across from it, and adjacent leg is actually what it's attached to. So this is the opposite leg, this is the adjacent leg to A, and then there's the hypotenuse. So for it, we need the opposite leg, which was A, and the hypotenuse was C. Now, usually these are going to be numbers. This is just example with generic letters. So if I do the sine of angle B, then in this case, I need angle B. Again, I'm doing sine, so I need the opposite leg from B, which is B. B and A are the legs. B is the one across from it. And the hypotenuse is C. And then we'll do one of tangent. Let's do tangent of A. Now, tangent involves both legs. So I need the opposite leg, this one, over the adjacent leg, which is here. So opposite over adjacent. Now, before we get into problems like you'll see in classwork, let me give you the abbreviation. It's actually, and usually I write it with capital letters. It's SOH, CAH, TOA. Now, most people say, oh, that would be hard to remember. But we say SOHCAHTOA. And there's a silly story about Chief SOHCAHTOA who, in an Indian village did something, but it's just a story made up, and that's just an easy way to remember, and that's the way most people teach it, is just remembering. And I always have said SOHCAHTOA, but then it gets confusing as whether you're saying S-A or S-O. So I'm trying to do better about SOHCAHTOA. And you'll see how we use it. So, problem number 1. Now, the only difference with this in your classwork will be one problem per picture. We're going to only draw 2 pictures, and that way, and we're going to do 2 problems for each one so that you don't have to draw so many different pictures. So I'm going to draw a right triangle. I'm going to draw it this way and set it up like they give it to you for classwork. Better draw the right angle first. Probably a little bit easier, and then draw the hypotenuse. Okay, we're going to call this triangle XYZ. And we're going to be given that the side across from Z is 12. That's the leg across from Z. The other leg here, ZY, is 16. And then XZ is 20. Now, if you didn't know one of those, you could have done the Pythagorean theorem, and that's probably what we will do in lesson 82. But I'm giving you these, but it is a right triangle, so if you square 12 and you square 16 and add those together, you will get 20 squared, which is 400, and so that does make that a right triangle. Now, we're going to do 2 things. Let's do this. Well, actually, we're going to do 3. Let's do the sine of angle X. Let's do the cosine of angle Z. And let's do the tangent of angle Z. Okay. And again, like I said, classwork's only going to be 1 picture, 1 step. This just saves us a little bit of time in our notes. Okay, so first thing I'm going to have this written where I can see it. So I'm going to say the sine of an angle is the opposite leg over the hypotenuse. So let's look at our picture. Let's find angle X, which is up here. And here's my 2 legs. So the one I want is the one across from it, so that's the 16. And then the hypotenuse is the 20. And you want to reduce these. So I'm going to divide by 4 over 4. And I get 4/5. Now what's interesting is if you drew a triangle bigger, if you drew a smaller one, and you do the sine of that angle, as long as they're similar. Remember, similar triangles have the same shape, same angles, but different sides. The sine of that angle X will still be 4/5 if it's a similar triangle to it. Now let's do angle Z. So start with Z. We want cosine this time, which is adjacent leg over hypotenuse. So if I go to Z, look at my 2 legs. This is the one adjacent over the hypotenuse, which is the 20, which again, we had it up here, is 4/5. And that's not a coincidence. It does happen that they end up being alike sometimes because you're really only dealing with 3 numbers, and you're making a ratio of any three of those, and sometimes they can repeat themselves. The tangent of Z is going to be the opposite leg over the adjacent leg. Well, find Z, and you need the two legs. Now, the one that's across from it is the 12, opposite over the adjacent, which is the 16. We can divide by 4 over 4, and we get 3/4. Okay, I'm going to stop and go to the next page. Okay, number 2. I'm going to draw my right triangle this way. Okay, we're going to call this triangle ABC. Now, this time, see, the right angle is B. I've always been used to it being C, but I did notice in the classwork. So you can't always depend on that. Look at the picture to see where that right angle is so you know which one is the hypotenuse. And they give us this leg is 40, this leg is 9, and the hypotenuse is 41. And let's do all three. Let's do the sine of angle C. Let's do the cosine of angle A. And let's do the tangent of angle A. Okay. I'll put my SOHCAHTOA at the top. I told my Algebra 2 class before spring break when they got ready to take the ACT, which hasn't happened yet, I said, write that at the top of your paper because that you'll need in some of the problems, and it's just an easy thing to remember. So in this particular case, I need sine of angle C. So first I need to find the angle. And with sine, I need the opposite leg. Okay, here's my two legs right here. So I've got the one leg across from it, and I've got the leg attached to it. And then I need the hypotenuse. Hypotenuse is always going to be your biggest one. So from angle C, the opposite leg is 40, and the hypotenuse is 41. And that one's nice. It's already reduced. Sometimes they are, sometimes they're not. Then the cosine of A. Here's angle A. Here's my two legs. I need the one that's adjacent to A, which is the 40, and the hypotenuse is 41. Now, if I had done the sine of, let's see, we did sine of C. If we did the sine of A, because I'm getting the same answers here, and I didn't want you to always think that they're always going to do that, because here's a case where if I do sine of A is the opposite over the hypotenuse, which is 9 over 41. It's going to be a combination of three of those numbers as a fraction, with two of those three numbers. So tangent is opposite leg over the adjacent leg. So I only need these two, and we're doing A, so I need the opposite leg, which is the 9, and I need the adjacent leg, which is the 40. And that one's also reduced. Sometimes they are, sometimes they're not.